Okay, 2.5 is the last section that we'll cover in chapter 2. So we're going to talk about absolute value equations and absolute value inequalities. In this first example, okay, so let's let f be a function. F of x is negative x plus 1. That's a line. The line has a slope of negative 1 and a y-intercept at 1. Okay, so 0, 1. I'll use that as a starting position and work off of the slope. The slope is negative 1. So I'm going up 1 into the left 1, up 1, left 1, up 1, left, or going up 1 into the left 1. That's the same thing as going down 1 to the right 1. Right? And I can gather up some more points flowing this direction. And then I would draw the line. Okay, there's nothing new there. We've already been doing that. Okay, so that'd be a quick rough sketch of the line y equals negative x plus 1. Now, I want us to graph y equals the absolute value of f of x. We already graphed y equals f of x. That's this guy here. So y equals the absolute value of f of x. Well, I can begin by plotting the points 1, 0, 0, 1, negative 1, 2, negative 2, 3, just like I did over here. And now another thing, so I know that anything coming out of the absolute value bars is never going to be a negative. Okay? And these points on this line that are below the x-axis, that's when y is a negative. All right? So if I throw absolute value bars on that, that means that the y values are going to be positive numbers. So all I'm going to do is I'm going to flip this part of the line that's below the x-axis so that it's above the x-axis. In other words, 2, negative 1 is going to be at 2, 1. 3, negative 2 is going to be at 3, 2, etc. Okay? And by raising that part of the line that's below the x-axis so that's above the x-axis, I end up forming a V. Okay, so one way to think about how we're getting the V is, I explained this when we were doing transformations, is kind of like taking two lines and sticking them together at a point. That's fine. Okay, another way to describe how we're getting the V is we have a line, right? And the part that's below the x-axis, I'm going to flip that so that it's above the x-axis, just like I did here. Okay, we end up forming a V. All right? Now, in this section, you're going to be solving absolute value equations and absolute value inequalities. Quite honestly, there's not many problems here with graphs, okay? But just to give you kind of a visual of what we mean by throwing absolute value bars around an expression, that's what we mean, okay? So let's take a look at absolute value equations first. And so it says, there's a definition there, let A be some positive number and U be an expression involving X. Then the absolute value of U equals A means that U is equal to A or U is equal to negative A. So whenever I'm solving an absolute value equation and I plan to lose the absolute value bars, I must write down two equations. The first equation is like pretending that the absolute value bars aren't even there. So I got U equals A. Or then the other one would be where I throw a negative on the right. U equals negative A. Be sure to lose the absolute value bars. Okay? So let's take a look at some examples. Now by the way, I see sometimes where a student is solving an absolute value equation and they will only have one equation when they lose the absolute value bars. Don't ever do that. Don't ever do that. You'll end up getting a wrong answer. Okay? You always have two equations when you lose the absolute value bars. So let's take a look at this example here first. I got the absolute value of 5 minus 3x equals 12. So, well, using this definition, u equals a or u equals negative a, my first equation is going to be 5 minus 3x equals 12, or then the other one is 5 minus 3x equals negative 12. Okay, and then now I'm back on more familiar ground here because I don't have absolute value bars in either of these two equations, and I can just solve as I normally would. So on this first equation, let's subtract 5 and divide by negative 3. 12 minus 5 is 7. And then when I divide by negative 3, I get negative 7/3. That'd be one answer. Go ahead and circle that. 5 minus 3x equals negative 12 means that when I subtract 5, I get negative 3x equals negative 17. And then when I divide by negative 3, negative over negative is positive. So x would be 17/3. That's another answer. Go ahead and circle that one. Okay. Now, I sometimes see where a student will throw away a negative value. Don't ever do that for these problems. Okay. The reason is because you won't have any answers that you're going to be throwing away. Okay. Like I could, if I wanted to, check that I get a true statement here on both these. Why don't we go ahead and do that? So like if x is negative 7/3, do I end up getting 12 out of this? Well, 5 minus 3 times negative 7/3, the negative 3's cancel. And so I'm left with 5 plus 7, that's 12. The absolute value of 12 is 12. And 12 equals 12, that's true. Okay, so negative 7/3, I'd circle that. Also, here's 17/3. So if I plug that number into the original equation, I have 5 minus 3 times 17/3, the 3's cancel. That leaves me with 5 minus 17, which is negative 12. The absolute value of negative 12 is 12. Okay, so the absolute value of a number is always going to be the positive of the number. So 12 equals 12, that's true, right? And 17/3, I'd circle that number. Okay. So both of these are going to be kept. Okay. Let's maybe try another example. What if I had the equation, the absolute value of 2x plus 9 minus 4 equals 15. Solve for x. So if I add 4 to both sides, the absolute value of 2x plus 9 is equal to 19. And so then using the definition for removing the absolute value bars, I have two equations here. 2x plus 9 equals 19, or 2x plus 9 equals negative 19. Okay, and then I continue solving for x. On this first equation, subtract 9, so 2x equals 10. X would be 5, then circle that number. And then over here, 2x plus 9 equals negative 19. When I subtract 9, 2x is equal to negative 28. Divide by 2, so x would be negative 14. That's the other answer. Okay. By the way, whenever you have absolute value equations, you'll always have two answers. That will always happen. Okay, so keep that in mind. By the way, here's another example. Okay, and you know, in this first one, so the first thing that I always have to do is I need to get the absolute value expression all alone and on the left. So in this example, where I got 2 times the absolute value of 3x minus 1 plus 7 equals 3, I want to first get the absolute value expression alone and on the left. All right, so let's subtract 7. We got 2 times the absolute value of 3x minus 1 equals negative 4, and then divide by 2. So the absolute value of 3x minus 1 equals negative 2. Okay, now there's going to be no solutions to this equation because I know that anything coming out of the absolute value bars is never going to be a negative. So the question here would be how many positive numbers are there that equal negative 2? None of them, right? There's no positive equal a negative. So no solutions would be my answer. Okay, be aware of that. I think there's maybe one problem or so where they have an absolute value equation. There's a negative on the right side, so that's always going to be no solutions. Okay, there's no positive equal a negative. Okay. Here's a definition next. Actually, why don't we go ahead and we'll stop the video right here, and I'll pick up with this definition in the next video, and we'll plan to finish up section 2.5 in the next video.